Welcome. This video explains how to communicate more effectively with AI systems by understanding prompt engineering to get better results. While this video focuses on prompt engineering techniques for Google's AI Studios, which uses Gemini, many of the discussed prompting methods also work effectively with other generative AI systems like ChatGPT and Claude by Anthropic. The key to effective prompt engineering is understanding what the AI can and can't do, using clear language, thoughtfully organizing your questions, and providing helpful context to your prompt. This video provides practical tips to get better results, common mistakes to avoid, and real-world examples to illustrate these principles. The goal is to empower you to interact with AI in a more productive and insightful way, even if you're not a technical expert. Let's start and see how you can create prompts that lead to more useful, relevant, and meaningful AI responses. In other words, get better results. LLMs function as prediction engines, analyzing text to determine what should logically come next in a sequence. Tokens are the basic units LLMs work with, parts of words, whole words, or punctuation. The model calculates probabilities for the next most likely token based on patterns from training data, explaining why responses may vary when asking the same question. Each generated token becomes part of the context window, influencing all subsequent predictions. This creates a chain reaction where each choice impacts future choices, allowing consistency across outputs. These predictions rely on statistical patterns in training data, which is why LLMs excel with well-documented topics but struggle with recent events, niche subjects, or tasks requiring true understanding rather than pattern recognition. Configuring AI text generators is all about finding the right balance of settings to meet your specific needs. The basic settings allow you to choose what the AI should focus on, whether that's homework help, creative writing, or something else. Text length is an important control. Shorter responses are more efficient, while longer ones provide more detail. Creativity controls let you adjust how imaginative and original the AI's output is. Lower settings for factual responses, higher for stories and poetry. It's important to experiment and test different configurations to determine the optimal settings for your particular use case. This allows you to get the best results from the AI, maximizing its capabilities while managing computational resources and costs. Temperature works like a creativity control for AI. Low settings, 0 to 0.3, make predictable responses like you'd want for homework help or looking up facts. Medium settings, 0.3, 0.7, give a good balance for everyday conversations. High settings, 0.7, 1.0, create more varied and surprising responses when you're looking for creative ideas. Choose the right temperature based on what you need, lower for accuracy, higher for creativity. For example, use low temperature when asking about historical dates or math problems, and high temperature when brainstorming for a creative writing assignment. At low temperature, the AI mostly sticks to the most likely answers, similar to how a textbook would present information. At medium temperature, it sounds more conversational, like talking with a tutor. At high temperature, it's more like a creative brainstorming session where unusual ideas are welcome. When experimenting with AI, start at medium temperature, around 0.7, and adjust based on what you need for your school project or activity. Let's examine two key sampling methods that complement temperature control. Top K sampling limits token selection to the K most probable options. Higher values, 40 to 50, allow more creativity, while lower values, around 10, keep responses focused and predictable. For example, in coding tasks, a top K of 10 to 15 helps maintain syntactic correctness, while creative writing might benefit from values of 40 plus. Top P sampling works with probabilities instead of fixed numbers. It selects tokens until their combined probability reaches threshold P, adapting well to different contexts. This is particularly valuable when vocabulary distribution varies. Sometimes a few tokens dominate, PC 0.3 captures essentials, while other contexts have flatter distributions requiring higher values, PIT 0.9 plus. Many practitioners combine these methods. For example, setting top K to 50 and top P to 0.95 creates a two-stage filter. First, top K selects the 50 most likely tokens, then top P further filters to those comprising 95% of probability mass. This approach prevents considering extremely unlikely tokens while maintaining contextual adaptability. At extreme settings, both behave similarly. Top K of 1 or top P of 0 is greedy decoding, while maximum values allow sampling from the full distribution. For technical documentation, try K20 pounds, P 0.9. For creative storytelling, K's 40 pounds, P 0.98 often works well. These are recommended starting settings for different types of AI output: balanced, creative, and factual. The balanced setting with temperature 0.2, top P 0.95, and top K 30 provides reliable, coherent responses with some creativity. Good for everyday questions, homework help, and research. The creative setting with higher temperature, top P and top K, generates surprising, unique content. Great for creative writing, poetry, and brainstorming. The factual setting with lower temperature and top values produces consistent, accurate responses. Best for science, math, and technical writing, where precision is critical. For math problems and coding, use temperature 0 to get the single correct answer. These are starting points. Adjust based on your specific needs and use cases. Zero-shot prompting is when you give an AI instructions for a task without providing any examples first. The key steps are: 1. Clearly define the task you want the AI to perform. 2. Provide the necessary information or content for the AI to work with. And 3. Review the AI's output and refine your prompt if needed. This approach works well for many everyday tasks where specific examples aren't necessary. It allows for quick, efficient interactions. While zero-shot prompting can be effective, more complex outputs may benefit from providing the AI with some sample examples to work from. The goal is to give the AI clear instructions so it can figure out how to complete the task on its own without needing to see demonstrations first. Building on zero-shot prompting, examples dramatically improve AI results. One-shot prompting provides a single template, ideal for straightforward tasks like product descriptions or translations. It efficiently communicates expectations through demonstration rather than explanation. Few-shot prompting uses 3 to 5 diverse examples to teach pattern recognition across different scenarios. Perfect for complex or nuanced tasks requiring consistency. Include examples that cover your expected output variations. Example-based prompting leverages the model's pattern recognition abilities, making it more efficient than detailed instructions alone. Invest in high-quality examples that truly represent your desired outputs to minimize refinement cycles. The 3 key techniques for effectively communicating with AI systems are system prompting, contextual prompting, and role prompting. System prompting sets the rules and boundaries for how the AI should behave and respond. Contextual prompting provides the AI with important background information to help it understand the situation, and context role prompting assigns the AI a specific character or identity which shapes its communication style and expertise. Using all 3 techniques together, rules, facts, and character, works best to get the most useful and relevant responses from AIA well-structured prompt that clearly defines the boundaries, provides the necessary context, and assigns an appropriate role will yield the most effective results when communicating with AI systems. Step-back prompting is a technique that helps AI models work better by starting with broader concepts and background knowledge before diving into a specific problem. The key steps are: 1. Look at the bigger picture and understand the fundamental principles. 2. Connect the problem to relevant knowledge you already have. And 3. Apply that background to tackle the original specific question. This approach activates the model's knowledge base up front, allowing it to reason more effectively about complex problems. For example, in a scientific domain like protein folding, you might first ask about general factors influencing protein structure before asking about a specific protein. Research shows this step-back prompting can lead to around a 20% improvement in performance on complex reasoning tasks in specialized domains. Chain of thought prompting helps AI models explain their reasoning step by step, just like showing your work in math. This structured approach guides the AI to follow a clear path from the question to the answer, reducing mistakes and keeping things organized. When the AI walks through its thought process, it can provide more accurate and reliable responses, especially for complex problems that require multiple steps of reasoning. Chain of thought prompting effectively bridges human-like problem-solving skills with the capabilities of advanced AI systems. Researchers have found this technique can improve performance on complex tasks by 20–40%, working best with larger models that can handle longer reasoning chains. Chain of thought prompting is incredibly easy to use. Just add, "Let's think step by step" to your prompts. No special technical knowledge required. It provides clear reasoning and shows how the AI reached its answer, making it easier to understand and check for mistakes. Chain of thought works consistently across different AI models with minimal changes needed, giving you reliable results. The main drawback is that it uses more computing power and costs more, but for complex problems, the improved accuracy is usually worth the trade-off. The transparency and interpretability of chain of thought helps build trust with stakeholders and saves time on debugging. Overall, the advantages of simplicity, clarity, and reliability make chain of thought a powerful tool, especially for complex reasoning or math problems. Self-consistency prompting is a technique that addresses a key limitation of standard chain of thought: inconsistent reasoning paths that can lead to incorrect conclusions. The process involves running the same prompt multiple times with high-temperature settings to generate diverse reasoning paths, extracting the final answers, and then using majority voting to determine the most likely correct response. This works especially well for problems with verifiable answers like mathematics or logic puzzles. While it requires more computational resources than basic chain of thought, it's still more efficient than full tree exploration. The key benefits are that it generates different approaches to solve the same problem, collects all the answers and results, and finds the most common answer, which usually gives more accurate results than just trying once. Think of it like double-checking your math homework in different ways. If you get the same answer twice out of 3 tries, that answer is probably right. AI does something similar with this technique. Tree of thoughts. It's a new AI approach that improves on single-path thinking by exploring multiple possible solutions at once. It's like a strategy game where you consider, if I do this, then what might happen next, for several different moves before deciding. Tree of thoughts creates a tree-like structure where each branch represents a different way of thinking about the problem. This allows the AI to try out different approaches, similar to how humans solve complex problems. Tree of Thoughts works best for games, creative writing, and step-by-step problem-solving with multiple possible solutions. The key innovation is incorporating self-evaluation, so the model can judge which paths are most promising before continuing exploration. Tree of Thoughts uses search algorithms like breadth-first or depth-first search to systematically explore the space of possible reasoning paths. REACT is a prompting technique that combines reasoning and acting capabilities to help AI models solve complex problems more effectively. The key steps are: 1. Reason about the problem and come up with a plan. 2. Act by using external tools like search engines to find information. 3. Observe the results and decide if the information is helpful. 4. Repeat the cycle until a solution is found. This cyclical process of thinking and doing allows the AI to leverage both its language understanding and its ability to interact with the external world. The integration of reasoning and acting is what makes REACT a powerful approach for developing autonomous AI agents that can tackle open-ended, knowledge-intensive tasks. Automatic prompt engineering, APE, is a powerful technique for optimizing prompts used to instruct AI systems. The key steps are: generate prompt variants, create different versions of the same prompt to see which one works best. Evaluate candidates, test each prompt version and compare the results using scoring metrics like blue or rouge. Select and refine. Choose the top-performing prompts and continue improving them through an iterative process. This allows the AI to optimize its own instructions, creating a feedback loop that saves time and delivers superior results, especially for complex tasks. APE is like having an AI assistant that helps craft the most effective prompts, automating a process that would otherwise be manual and time-consuming. Effective prompt design is crucial for getting high-quality results from language models. Providing clear examples shows the model what you want, creating a template for it to follow. Keeping prompts simple and straightforward avoids confusing the model and yields better outputs. Being specific about the desired format, style, and content requirements helps the model understand exactly what you need. Framing prompts as instructions rather than restrictions gives the model clearer guidance on what to do. Using action-oriented verbs like analyze, compare, define communicates your intent more effectively. Refine prompts iteratively based on the model's responses to get increasingly accurate results. Let's explore output control techniques for AI language models. These strategies help you get precisely what you need while managing efficiency. Token length control improves efficiency and reduces costs. Be specific about desired response length in your prompts to save tokens and focus the model. Parameters like max tokens or phrases like keep it under 100 words enforce brevity. Variables enable scaling in production environments. Create templates with placeholders like customer name that your application can automatically fill, making your system flexible and maintainable. Format experimentation is essential. Try structuring prompts as questions, instructions, or dialogues. For analytical tasks, requesting structured outputs like JSON or XML reduces hallucinations and improves response quality by providing a clear framework. Consider combining these techniques for optimal results. The most effective prompt engineering often leverages all these methods simultaneously to achieve precise, reliable outputs. 2 key practices for getting better results from AI are testing different approaches and keeping good records. When testing, change one thing at a time, like how formal your language is, which words you use, or how you give instructions. For multiple choice questions, try changing the order of the options to make sure the AI isn't just picking the first or last choice. Try asking the same question in different ways and notice which version gets you the best answer. Keep records of everything in an organized way: what you asked, how good the answer was, what settings you used, when you did it, and which AI model you used. This creates your own reference guide that helps you avoid repeating mistakes and shows you what works well. The goal is to use your best questions consistently. Create a saved collection of questions that work well so you can use them again for similar projects in the future. Creating AI prompts is like a science experiment. Start by trying different ways to ask your questions. You could give the AI specific instructions, assign it a role, like be a history teacher, or adjust settings to make it more creative or more precise. When you get your answers back, check if they're correct, complete, and have the right tone. Notice which questions got you the best answers and where the AI got confused. Keep notes about what you asked, what settings you used, and how well it worked. These notes will help you remember what works next time. The more you practice, the better you'll get at predicting what kinds of questions will give you the answers you need. Thanks for watching our presentation about prompt engineering. Please like this video so more people can find it. Subscribe to our channel to know when we post new content and share it with friends who might find it useful. We really want to hear what you think. Leave comments to tell us what topics you want to learn about next. Thank you.